But nonetheless, the break has been made. We come up next to what we call the Age of Enlightenment, which really is brought in by the thoughts of René Descartes, the great French philosopher. Descartes is trained in Thomistic philosophy. In fact, he is perhaps overtrained in Thomistic philosophy. He reacts against it. And he goes off to develop his own way of thinking about the world. In Descartes' way of thinking about the world, he tries to simplify it, and he tries to say the first thing that exists is thought. Not the external world, the way Thomas would have us think, but that thought pre-exists that in his nature. So he has thought being something that makes him be, that because he thinks, he knows that he is. Of course, Descartes knows that God is. He says, because I am, God exists. And that's all consonant with what went before. But his schism between the mind and the body, between thought and the material world, begins this duality that descends to us today in what is called the Cartesian frame of thinking. After René Descartes comes Sir Francis Bacon. Bacon is really the first of the great Enlightenment thinkers who is credited with developing what we now call the scientific method. That means the method by which we experiment, we develop hypotheses. Well, first we observe, we develop a hypothesis to explain the observations. We might develop experiments to try to test the hypothesis, and then we judge whether that hypothesis is correct or not, and we go on to a new hypothesis with new observations. Bacon is really the one who comes up with what is called the hypothetico-deductive method. By the way, deduction is not the only method in science. There's also induction. There's also retroduction. So there are several different methods, but I'm going to focus on what we call the hypothetico-deductive method, since modern biology uses that methodology almost exclusively in its experimental approach. Francis Bacon is a great physicist and a great philosopher, actually a better philosopher probably than a physicist. We remember him more for his philosophical approach to science than we remember him for his scientific achievements. But another contemporary, another Enlightenment scientist is Isaac Newton. And Sir Isaac Newton really is the pivotal point in our thinking about science and its development on the way. Notice that we haven't been talking much about biology at this point. We're really locked onto physics and philosophy as the background, and there's a very special reason for that. At this time in the development of science, it's really physics which is at the pinnacle of achievement, and biology is still pretty much an observational discipline. I'll come back in a moment to what I mean by that. Isaac Newton develops for us next his ideas about physics. You'll notice that we've been talking mainly about philosophy and physics and not so much about biology. And that's because physics at this time of the development of science is really at the center of attention for most of the both philosophers and scientists of the day. Isaac Newton observes the world around him, but does something very special. He begins to describe how the world behaves, the physical world around him, in mathematical terms. In fact, Newton develops a mathematics specifically for the description of that world. He develops calculus as a way of being able to speak about the motion of things he sees in the world. Aristotle referred to motion hundreds of years before this, but not in strictly mathematical terms, only really in descriptive terms. Now Newton is able to write down mathematical statements which in fact describe the motion of things that he sees in a predictive fashion, so that he can say if a body has such a certain mass and a certain velocity, then it will have a certain force that it exerts on another body. This is a very important advance in our thinking, both scientifically and philosophically. With Isaac Newton, science reaches a maturity, we'll say. I'll use the word maturity because it now has both a theoretical basis and a language which it speaks. Let me back up and say what I mean by that. When I say that science has a theoretical basis, I mean that predictions can be made from this theory. So given Newton's laws of motion, one can look at a body at rest or a body in motion and make a prediction about what will happen next. This is the theoretical basis of it. To say that it has a language means that it has a way of, in signs and symbols, describing the physical world in a way that can be communicated to other scientists, in a way that is very rigorous. And the use of mathematics as a language then makes what scientists, especially physicists, call physics a very mature science. Now, what is the state of biology in the Enlightenment? What has happened to biology while Newton has been busy writing his Principia Mathematica and his treatises on motion? Well, biology is still very much a descriptive science. Prior to the age of the Enlightenment, from the time of St. Albert the Great forward, biology has been involved with describing the world around it as a series of descriptions of those creatures in the world. And the way of describing those creatures was called the polynomial description. Polynomial means that each creature, each plant, each animal, had a series of names to describe it. And those names were basically Latin descriptions of the properties. So, for instance, I might describe one of these cacti as a cylindrical green object with ribbed veins going up and down it, and with flowers on the top and thorns coming out. And all of those words in Latin would be used to describe that as a unique thing. This made description of the biological world very, very complex, because each entity in the world, as you discovered it, especially with the opening up of the New World, would have to have its own set of polynomial descriptors. So it became a very complex system. And it was at the beginning of the 18th century that Carl Linnaeus, a Swedish botanist, proposed a new system of classification, which is called the binomial system. In the binomial system, Linnaeus proposed that every creature would simply be given two names, which we now know as the genus and the species name. Linnaeus used two Latin descriptors for each creature, each plant, each animal that he wanted to describe. And then as a subtext to that, he'd write a description of that thing. So, for instance, we would call our family dog Canis domesticus. And under that description, Linnaeus would write what a dog is about. So the binomial system simplified greatly the descriptive work of biologists and botanists. And that has come down to us today. It's still the names we use for creatures around us. We use the genus and species name. Now, Linnaeus's proposal to put everything in this binomial form brought descriptive biology under control, we'll say. But notice that we still don't have a theoretical basis for the biology, and we still don't have a specific language. Oh, yes, Latin is being used in the names, but that's not really a language that's specific to biology. Specifically, we don't have a theoretical basis to use for prediction. And with that, we would have to say that biology, at the time of the Enlightenment, in the age of physics being the glory of the sciences, still remains as basically an immature discipline, one without a theory and without a specific language.